Alright, these are your notes for section 7.4 on trig ratios, and this is the example part of these videos. We've already learned the setup, what the trig functions are, the vocabulary words. Here we're going to put those words, those vocabulary words and those functions into some examples and see what you're going to have to do in class. Now, what I want you to remember, the so-katoa part. Some old hippie came a-hoppin' through our apartment. This is the setup, okay? The sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent side over the hypotenuse. The tangent of an angle is the opposite side over the adjacent side. That's how we set these up. So let's look at an example. Example 1 here. We have a triangle. It's a right triangle. Remember the trig ratios, they only work on right triangles, so if you don't have a right triangle, you won't be able to do these problems. Here we do. We have 3 sides, side 6, side that's 8, and a side that's 10. Now, our trig functions, our problems are over here. And notice that they're all based off angle A, which is up here at the top. That means our opposite, our adjacent, and our hypotenuse are based off this angle. So this would be the opposite side. This is the adjacent side, and this is the hypotenuse, based off of angle A, okay? Now, in this example, they're all the same. As we go through, it's going to change. You may have different angles in the same set of problems. This problem, though, they're all based off angle A. So opposite, adjacent, hypotenuse, they can stay there for the whole problem. All right, first example is we want the sine of A. Okay, remember S-I-N, we don't say sin of A, we say sine of A. Sine of A, which is the opposite over the hypotenuse. Now what we do is we take those values that are on those sides. The opposite side, it has a value of 8, and the hypotenuse has a value of 10. So we have 8/10, and we're going to reduce that. Numbers that go into both of those are 2. 2 goes into 8 4 times, and 2 goes into 10 5 times. So there's our answer, 4/5. The sine of A equals 4/5. Okay, pretty simple. All we're doing is pulling off the values for the sides and setting up fractions out of them. Second one, cosine A. Still off angle A here, but cosine is adjacent over hypotenuse. It's CAH, okay? So our adjacent value here, the side next to A, is 6, and the hypotenuse is 10. We need to reduce that. 6/10 becomes 3/5. So there's the cosine of A. It's 3/5. Last one, the tangent of A. Tangent, remember, is opposite over adjacent. It's the TOA part. So we want the opposite value, which in this case is 8, and the adjacent value, which is 6. And we're going to simplify that. 8/6 becomes 4/3. So the tangent of A is 4/3. Now that's what you're going to be expected to do. You have to come up with the ratio for the angle that they give you. Okay? Let's look at the second example, example 2. We have a triangle. We have triangle DEF. It's a right triangle, and we have sides that are 10, 12, and 15. Notice this time, though, that these first 2 examples are based off angle D, and this last example is based off angle E. That means that our opposite, adjacent, hypotenuse are going to switch for those types of problems. The ones off D will have opposite, adjacent, hypotenuse set in one spot. The problem based off E is going to have a different opposite, adjacent, and hypotenuse. Okay? Now, let's work through these first 2, the one with D. They're going to be based off this angle here. That means that this is our opposite, the one across from D. Adjacent is the one next to D. And then the hypotenuse is the longest side of that triangle. Okay? Well, we want the sine of D. Sine, again, is opposite over hypotenuse, sorry. Opposite over hypotenuse. Well, our opposite side is 12, and our adjacent side is 15. Numbers that go into both of those are 3. 3 goes into 12 4 times. 3 goes into 15 5 times. So we end up getting 4/5. Cosine of D. Same idea. This time, though, we want the adjacent over the hypotenuse. The adjacent side to D is 9. The hypotenuse is 15. That reduces down to 3/5. So the answer for the cosine of D is 3/5. Now, E is different. I am going to redraw the triangle, and you'll see why here in a second. D, F, E, 9, 12, and 15. This time we're based off angle E. That changes our opposite, adjacent, and hypotenuse. Now, if we're going off E, that means this side is our opposite side, the side that's across. This one is our adjacent, and 15 still stays the hypotenuse. Hypotenuse didn't change, but the opposite and adjacent, they switched for this one because we're based off E this time. Okay? That's where people start to get confused because all these will be mixed up in the same problem. You really have to pay attention to what you're doing. Okay? Let's finish this one. This one we want the tangent of E. Tangent is opposite over adjacent. Well, the opposite of E, the one across from E, is 9, and the adjacent one is 12. 9/12 becomes 3/4. Okay, so there's our ratio for the tangent of E. It's 3/4. Again, we have to change our opposite adjacent because we're based off of a different angle this time. All right, we have one more example. Example 3. Example 3, we have triangle XYZ. It's a right triangle. One of the sides is the square root of 6, one of the sides is the square root of 7, and one of the sides is the square root of 13. Okay, we're going to notice the first one is based off of X. We want the sine of X. The second two are based off of Z, so at some point we're going to have to switch. We're going to start with X. This time I'm not going to label opposite, adjacent, and hypotenuse. We're going to see if we can talk through it. Sine of X. Remember, sine is the opposite over the hypotenuse. Well, the hypotenuse is going to be square root 13. That does not change throughout the problem. So we know our denominator is going to be the square root of 13. We have to figure out, though, what the opposite is going to be, and that's the side across from X. Root 7 touches X, so the side across from it, opposite, is going to be the square root of 6. So there would be our answer, the square root of 6 over the square root of 13. Now, I will let you leave it that way. We really cannot leave it that way in terms of math because we have a radical in the denominator. We would have to rationalize this. So I'm going to walk you through rationalizing it also, just so we remember how to do that. Because on your work, the directions may say to leave them as an unsimplified, unrationalized fraction. Directions may say to rationalize it. So you need to be familiar with how to do both. Okay, so we're going to go ahead and multiply by the square root of 13 over the square root of 13. That's going to get rid of the radical in the denominator. 13 times 13, or root 13 times root 13 is going to be the regular old 13. And then in the numerator, we have 6 times 13, which is 78. Okay? Now, I know 78 is not going to break down. Here's how I know, because I multiplied 6 and 13 to get that, neither of which is a perfect square. So I can stop there. 78 is not going to break down because I know the two numbers I multiplied to get it. So this is a better answer than the first one, but I would probably take both. Okay, so be familiar with that. Be familiar, recognize that you should rationalize that denominator though. Alright, the second two examples, they are based off angle Z. Now, remember we said opposite adjacent switch when we change angles. Hypotenuse doesn't though. Okay, so the first one is the cosine of Z. Cosine is adjacent over hypotenuse. Hypotenuse doesn't change, it's going to stay square root 13. But we want the side that's adjacent to Z, the one that's next to Z. And in this case, since they switched now, root 6 is the one that's next to angle Z. So it's root 6 over the square root of 13. That means our answer is going to be the same thing if we would rationalize it. Okay? And that's okay. Some of your answers will repeat, especially when the angles change. Okay? And that's okay to have two of the same answer in the same set of problems. Last one, we're going to look at tangent of z. Tangent is opposite over adjacent. Now the opposite side to z, the one across from z, is the square root of 7. The side adjacent to z is the square root of 6. So we have the square root of 7 over the square root of 6. That's our unrationalized answer. If we're going to rationalize it, we need to multiply the numerator and the denominator by the square root of 6, because that will get rid of our radical in the denominator. Root 6 times root 6 is the square root of 36, and the square root of 36 is 6. And then we have 7 times 6, which gives us the square root of 42. Now there would be our answer. Again, for the same reason I talked about how 78 won't break down, I know 42 is not going to break down because I multiplied 7 and 6, both of which aren't perfect squares. Okay, so I know 42 isn't going to break down for that reason. Now hopefully that makes sense to you, these trig ratio parts. Really, you just have to figure out the angle and where the opposite and the adjacent side are for each one. That's the tricky part though. So if you need to label them in a picture, that's fine. Realize though, when you change angles, you may have to redraw your picture like we did on example 2 when we talked about E. Okay? Which is fine. That's perfectly fine to do that. If you have any questions, go back and rewatch this video on the examples, or if you need to go back and rewatch the one on vocabulary, do that too. If you still have questions, bring them to class next time, and we'll help you answer them. Remember, you also need to bring a calculator next time that has sine, cosine, and tangent buttons on it. You will use it in class. You didn't use it in the video, but you will use it in class.